Alright, so here we are, Unit 7, Lesson number 4, and we're going to be looking at one of your reference tables, and this is a reference table that they ask about all the time. So you should certainly have your reference tables out. And this is about reference table G, which is a solubility curve, and we'll be doing a lab on this. We'll come up with our own solubility curve for a salt. So what table G is basically a graph. It's a graph of temperature on the x-axis versus solubility of salts on the y-axis. And instead of having just one line, it has a dozen or so lines. So it's a graph that has the data for 10 or 12, the solubility of 10 or 12 salts. So it's a little bit unusual. And basically, it has the data for the temperature of the solvent on the x-axis, and y would be the solubility in grams of solvent of each of those solutes. And again, we talked about this before. These are more qualitative measurements of solubility, meaning you don't get a number, it's just describing it. Dilute means you have a small amount of solute, concentrated means you have a large amount of solute. We already know what a salt is. It's an ionic compound, and ionic compounds are composed of a positive ion and a positive metal ion with a negative nonmetal ion. So this is nothing new here. How do we use this chart? Well, this is a solubility curve for just one particular substance. And you remember how we talked about in the previous lesson, we talked about these three terms: saturated, unsaturated, and supersaturated. And honestly, the only time they refer to these is when they give you the data for a solution and ask you, would that solution be saturated, unsaturated, or supersaturated, meaning this. Let's say, for example, and it's probably easier to give you an example. Let's say that this line represents, this is substance XY, a solute is XY, and we have, we have 60-degree temperature water, and in that we have about 120 grams of XY dissolved in it. And they would ask you, is that saturated, unsaturated, supersaturated? So what you do is you take a look at the temperature, which is here, follow it up, okay, and here, see, this is where the line crosses. And if you move over to the left, carefully, that number here, this is how much would dissolve in it. Let's say that would be 115 grams, or in this case it's kilograms, but we'll say grams. That would be a saturated solution. That's the maximum that it can hold at that temperature. But we're saying we don't have 115. We actually have 120 grams, which means that that would be right here. So it's above the line. So that would mean that it is a supersaturated solution, because the data that we gave indicates that the point would be above the actual line. So if it's above the line, it's going to be supersaturated. If the point that we give is directly on the line, it's saturated. If it falls anywhere below the line, it is unsaturated. And that's what this is all about. And I'm sure you'll see this when we do the classwork packet. So again, if you want to write it, this would be supersaturated, saturated, and down here somewhere would be unsaturated. Well, let's get into table G. Actually has a lot more curves than lines than just that one. So let's take a look. This is a couple of things that I want to point out to you, and unfortunately it doesn't all fit on the slide, but we can make do. A couple of things that you should probably write on your reference tables if you have it with you. Again, temperature is the x-axis, that is down here, and this is the solubility of each solute in 100 grams of water. So basically what you have is you have picture this in your head, you have a beaker of water, and in that water is 100 grams, which is the same thing as 100 milliliters, right? Because the density of water is 1. And you have this water at different temperatures, and you can test the solubility. Now, it's a little bit more complicated than that, but you kind of get the idea. What I'm trying to point out to you is, in this particular case, is if you look at all the lines, notice how the majority of the lines, as you move from a lower temperature to a higher temperature, actually go up. Like Ki, if you look at it, that goes up, that goes up, that goes up. But you're going to notice that there are three substances, HCl, SO2, and NH3, whose lines actually go down as you move from left to right. In other words, they become less soluble. So HCl, NH3, and SO2, actually become less soluble with increased temperature. That's kind of an important point. Why is that? Well, that's because these are all gases. These are solutes that are gases at room temperature. Remember we talked about earlier that gases actually, when you raise the temperature, they actually become less soluble. So those three are gases. The other ones are all solids at room temperature. So they all do increase with solubility as temperature goes up. And basically the most common thing they do here is they'll give you a temperature and ask you for the solubility. So they might say, and we're going to get into this, they might say, what's the solubility of, let's say, KNO3 at, and we'll pick a temperature, and if you don't have your reference tables, you're not going to be able to see that, at 70 degrees Celsius. Well, 70 degrees is right here. So we're going to follow this line up until we hit the line, a little off, until we hit the line for KNO3, and it's right here. And then we read over. And we'll say that that's about 134 grams, which means that 134 grams of KNO3 will dissolve in 100 grams of water at 70 Celsius. That would be a saturated solution. That's the maximum solubility for that substance at that temperature. Okay? One of the things, what else did they do? Well, many times what they'll do is, it's not really trying to fool you, but in a way it is. You notice how in this case the y-axis is labeled 100 grams of water? Well, sometimes they might say, well, instead of 100 grams of water, what about if we used double the amount of water, 200 grams of water? What would that do to these numbers? Well, it would double these numbers, because if you double the amount of water, you'd be able to dissolve twice as much solute. So in this particular case down here, if this was 200 grams of water, this number would be 268 grams. They may also use 50 grams of water, which is half of this. So whatever you would get here, you'd have to cut that in half. So in this particular case, it would be 67 grams would dissolve in only 50 grams of water. And that's really most of what they do in this particular thing. And again, remember, they also do the saturated, unsaturated, and supersaturated, right? So you have to be careful with that on this graph. So here's a couple of practice questions, and I put the chart right next to it. So it says here, and again, let me get this. I don't know why this keeps doing this. So let's take a look at what it says. A solution contains 14 grams of KCl in 100 grams of water, so we're good. We don't need to worry about doubling or cutting in half. And the temperature of the water is 40 degrees. And what they're saying is, well, how much more can we add of the KCl to make it saturated? Which means that obviously this is an unsaturated solution. But let's check it out. Here's the 40-degree line right here. And we're going to follow it up until we hit the line for KCl, which is right here. And that's about, let's say, 39 grams. That's the maximum that it can dissolve. That would be a saturated solution. But we only have 14, right? So it would be, I'm sorry, 39. I put 29. It would be, no, I did put 39. 39 is the maximum. We only have 14 grams. That means I can still dissolve an additional 25 grams. Okay? That's an example of one question they do. And next one. Notice in the next one, however, it says 200 grams of water. So now we have to be careful. Now we know that we're not using the 100 grams. How many grams of the compound KCl must dissolve in 200 grams of water to make a saturated solution at 60? Well, here's the line for 60, right? And we are doing still KCl. And here's the point at 60 that would be saturated. And if we move over, I'm going to say it's about 45 grams, but that's for 100 grams of water, so we'd have to multiply that by 2. So the answer to this would be 90 grams. And that's two of the good examples of how you would use reference table G. Okay. Now number 3 is the same thing, asking you. I don't know. I thought I had put a reference table. I did. Let's take a look at why this is unsaturated. You look at 20 degrees, which is right here, this line right here, and you have 20 grams of KNO3. Well, you can see that KNO3 can dissolve. If you look here, and again, this thing keeps going. At 20 degrees, KNO3 can dissolve 35 grams. So that's still 15 grams underneath. That's a unsaturated solution. Let's take a look at the next one. The next one is KClO3 at 40 degrees. And where is KClO3 at 40 degrees? Here's the line right here. Oh, I'm sorry. Here's the line for KClO3. You got to be careful. That might be, let's say, 17. Well, if you have 20 grams, but it can only hold 17, that's a supersaturated solution. And I think you can get the rest. I just don't want to make this video way too long. It's already 11 minutes long. Okay, so that's it for that. So that's the end of this lesson.